There are two angles that you need to think about when looking at the applications of trigonometry. The first angle is called the angle of elevation. So from your line of sight along the horizontal, if an angle goes up from the horizontal, that is called the angle of elevation. So think of elevate meaning going up. The other angle, again from the horizontal and going down. So this angle here goes down. This is called the angle of depression. And again, you can think of depression as going down. This angle goes down from the horizon. Let's look at a couple examples of these. So in this first example here, we're standing 250 meters from the base of a cliff. There's a 31-degree angle from your feet to the top of the cliff. How tall is the cliff? Well, let's just draw a picture of what we know first. So here you are, and here is the ground, and here is the cliff. So we're told that this distance here is 250 meters. And we're also told if we draw a line from our feet to the top of the cliff here, this angle is 31 degrees. And we want to know what this height is here. This is the cliff. Now let's take a look at this angle. So we know that this is 31 degrees. It's an angle of elevation. So here's our horizon. That's the horizon from the feet, and going up, that's 31 degrees. So trying to find what the height of the cliff is, we want to look at our trig functions. And in this case, we have an angle, we have the side adjacent, and we're looking for the side opposite. So we want to use our tan function, which says that tan of an angle is equal to the opposite side over the adjacent side. So here, let's fill in the information we have. We have tan of 31 degrees. We don't have the opposite side, but we do have the adjacent side. So let's go ahead and solve for h. Here, if we multiply both sides by 250, those cancel, and we're left here with h is equal to 250 times the tan of 31 degrees. And if we work that out on our calculator, we should get that h is equal to 150.2 meters. And that is the height of the cliff. Okay, let's look at another example. In this next example here, we have a fir tree. And this fir tree is 85 feet high, and it casts a shadow of 47 feet. What is the angle of elevation of the sun? Well, again, let's draw out what we know. So first of all, we have a tree. Here is our tree. And we know that the height of this tree is 85 feet. Now we also know that it casts a shadow of 47 feet. So here is our shadow. And we know that this is 47 feet. Here. So where is this angle of elevation to the sun? Well, if this is our shadow, that means that our sun must be over here somewhere, because it's casting a shadow down this way. which means that if we drew a line from here to our shadow, then this is our angle here. And remember, this is the angle of elevation. It's going from the horizontal up. So that's an angle of elevation. So let's find what that is. Now, first of all, we need to know what information we have. Well, in accordance with this angle, we have the opposite side and we have the adjacent side. So again, that leaves us to use our tan function, our tan ratio. So here we would have tan theta is equal to opposite over adjacent, and let's fill in what we know. So tan theta is equal to 85 over 47. Now, what we don't have is the angle, which means we have to use the tan inverse. So theta is equal to the tan inverse of 85 over 47. And if we work that out on our calculators, we should get theta is equal to 61 degrees. So the angle of elevation to the sun is 61 degrees.